Okay, now we're recording. So we're going to create the directory your name underscore do more, create the ladder logic programs for each of these tasks, save those files in there, and then when we're done, we want to zip that all up and load it up into Blackboard. Okay, so let's go ahead and start the software. Okay, so and actually I have the software started, but I need to, I'm going to start a brand new one. So I'm going to create a new project here. Okay, and I'm going to select offline. And when you create a new project, this is kind of like with the Allen Bradley software. One of the first things you really got to do is select which PLC you're going to be programming to. And you need to do this so it has an idea of like how many timers that you might have available to you, and what type of hardware you may have embedded into it, and those various items. Okay, so for us, we're just using this simulator here. So I'm going to make sure I select the Do More simulator. Okay, and I'm going to say OK. And that's some kind of communication thing here, but the problem is I already have one of these open. And so I'm just going to ignore what I've got here. So I'm going to say don't save, and it should wipe everything out and give me a fresh screen here. I'd like to see the detailed error list. No, I don't want to look at no error list. I just want a fresh screen. There we go. Excellent. Okay, so now we've got this fresh screen. And the first thing I'm going to do, I guess, before I even really do any real work to it, is I'm going to come over here and I'm going to say save project as. Okay. And then what I want to do is I want to save this, and I want to save it where I can find it because we need to upload it. Okay. So if you want, it's kind of up to you guys. If you want, you can just maybe probably go to documents. All right. And then under documents here, we can create a new folder. And this is where we're going to have your name. So I'm just going to put like Hartman. Okay. Underscore. And see, I got to go back to the lab and look just to make sure I called that do more, right? So when there's Adobe. Okay. So it's going to be your name and then underscore do more. All right. So that's what we're going to name this directory. And since I left the screen, it put it there before finishing. So I'm going to come back and fix the name, Hartman Do More. All right, so this is going to be my directory. I'm going to save this in. All right, and so the first file I'm going to, the first program we're going to be creating is conveyors. So I'm going to give the file name here, conveyors. And so, and then you could come in here, you could give it a description. Lab exercise 1, and all this kind of stuff, and you can put in all this various information here. Okay. All right. So now, so I've created the file, I've created the directory somewhere where I can find it, right? So if we just go back and look at our window manager, right? If we look under documents now, I should have Hartman Do More under documents, and then in there, then you should see this conveyor. All right, and there's actually several different files here under this, but which is kind of why we wanted to make sure we had a directory and have all this in here so that we can zip up the entire directory. Okay, so all right, so given that, then what we can do is we can come in here and we can build our logic. Okay, and I'm not going to do the logic that you guys need to do for the lab. What I'm going to do is just going to kind of show you some things with the software here, remind you of some that we talked about last week, and show you some things we didn't talk about. All right, so first of all, we want to do a fill-in circuit. And, you know, typically we do our stop buttons are wired as normally closed. And so therefore, when we do the ladder logic, we actually, inside the Ellen Bradley PLC, or maybe even this one, we actually wire it with a, in the ladder logic, we actually use a normally open contact instead of normally closed. However, with this simulator, if we do that, we got to remember that we got to go in and click it closed every single time. So I actually, as I've been kind of messing around with it, I've decided I like to do the stop button as a normally closed contact. All right, so one thing I want to point out to you though is you come over here and you select your items. If you just hover on it, all right, it gives you all this instructional help, which is very nice, I think, that they give you this. So I'm going to click on this and drag it over here and put my normally closed. All right, and inputs start with an X. So we have X0 would be the very first input, and then we just click on that little check mark there to apply that, and that's going to be my stop button. And then I'm going to select a normally open here, and that's going to be X1 is my normally open. You can also hit enter, but if you come back in and you decide you got to make a change to this, then you just need to hit that checkbox to apply that change. All right, so now what I want to do is I want to drop down here so that I can have my fill-in bit. Okay, and so I'm going to come over here. I'm going to use my wheel mouse. If you have a wheel mouse, I'm going to use the wheel mouse to scroll up and down over here to choose these, and I'm going to select this wire down. Okay, so I'm just going to wire down, and I'm just going to click on this and drag the wire down and drop it right on that contact where I want to drop that down at. Okay, and now I'm going to scroll back up here, and I'm going to grab my other open contact, and I'm just going to kind of put it right here where the gray box is. And then I can put that in there, and C0 is like a memory bit. So that's like a virtual bit or a virtual relay. And I'm just going to go ahead and let it take that. And then I need to get the wire up. So I'm going to come back over here, scroll back over here, grab the wire up, and I can put that there. Or read, if you look, right, if you look here, it says wire up, control up arrow. So actually, if I click on this, if I just click on that there, hit escape to get rid of the help thing, and I'm going to do a wire up. Okay, I'm going to do a wire up by doing control, what was it? Control up arrow. I think I need to arrow over. You can use your arrow keys to move around here. Okay, so I don't want to be on this. I want to be right there. So this is where I want to be. I put the little box right there, and then do a control up arrow, and it will link me back up to the main rung. Okay, so if I want to get rid of that, I click on it and hit the delete key. Okay, and you got to be careful. I'm going to apply. One thing you got to watch is it likes to undo a lot if you do it here. So you need to kind of like come in and accept these. Okay, and I guess it's complaining because I haven't applied an output yet. Okay, so I'm going to come over here to my coil, and I'm going to choose a out coil and drop in there, and of course that's going to be C0 again. Okay, and now I'm going to apply this rung. Okay, and then Okay, it undid that entire box. Okay. All right, so, well, looks like I just lost everything. Okay, so I don't know, it's still kind of working out some of the things here. So if I let's see, I'm going to put my start bit here, so that's going to be X1. And then I forgot I wanted to put the stop there. So if I drag this stop over, I like to have the stop to the left. Logically, it doesn't matter, but I just kind of like that. And so, and I put the start button here first. Okay, so what I'm going to do is I'm going to drag this over and drop it right on top of that. And it gives me a choice now. Do I want to insert to the left or do I want to overwrite it? Okay, so if I do an on top, it's replacing overwriting what I had. But if I select the second radio button, it moves it to the left. And then, of course, that's going to be X0. Okay, and then I want to have my wire down. Okay, so I'm going to do a control down, pops that down there. And then I can bring in my C0. And then I'm going to control arrow back up to get that. Then I'm going to go to my coil. Okay. And I'm going to put my coil here, and that's a C0. Okay. Now, once the C0 bit is set, then what I want to do here is come back to my contact. So when C0 is true, I'm going to enable a timer. Okay, so I'm going to come down here. I'm going to enable a timer. And so down here, I'm going to grab timer. And when you select a timer and you just bring it in there and put that in there, they give you lots of choices for timers. You can do a accumulating timer. You can do an on delay. You can choose an off delay. But notice here, it's like when you choose these, it says has an output bit. Okay. Okay, can't see the right side of the screen, getting cut off there a little bit. Okay. All right. I don't know. I mean, I can see. Maybe is it? Can you see it all there now? I mean, that, yeah, that was. I came over here. I don't know. It's showing on my Blackboard screen. I can see these are all the choices over here. Okay. All right. So yeah, when the timer box opens, okay. So this is the timer box, and you know, basically, if you just choose the default one, it's a timer on, and you know, so you're good there. And so, and then the timers are just named like timer 0, T0, T1, T2, T3. And we can come in here and double click on the preset value. And I'm just going to make this like 3 seconds. Okay. And so this timer is going to count for 3 seconds. And again, I'm not doing your lab for you. What I'm doing here is just kind of, you know, showing you some of these exercises. And again, I am recording this so I can make this available so you guys can watch it again as you work through the lab. Okay, so as we go through this, then so the timers are over here. Timers are way down here at the bottom of the screen. Okay. And there's also counters. So the next thing I'm going to do is I'm going to select a counter up, and I'm going to drop that in there. And counters are CT0, CT1, CT2. And by default, it wants to put the preset for the thing. It wants to use a an integer value, which counters really should have integer values, but it's using DZ0, which is a storage location. So if you want to, you can just override that and just put in a number. I'm going to say, I don't know, 15 or something here. All right. And so when you add in the counter, notice it has, this is a counter up, and then it also has a reset. Okay. So you got to kind of be careful here, because you don't want it to just reset any time. Okay. So what I'm going to do here is I'm going to come back up to my contact. I'm going to put a contact over here on the up rung and say when timer T0 is done. So I'm going to type in here T0 dot, and then notice here when you hit that dot, it's kind of just like the Allen Bradley software. It gives you all your different choices here. Okay, it knows that this is a bit, so it doesn't give you like your accumulator choice, but so you got done, and they give you done just in two ways, either DN like Allen Bradley or spelled out. Okay, so I'm going to choose timer done. As far as I know, there is not a difference between done and DN. I think it's just a preference. Okay. So I haven't really tested them, but I know done definitely works just like the Allen Bradley. And since that's what we're most familiar with, at least in the class, that's what I'm using. All right. But now I want to be able to reset this counter. Okay. So what I'm going to do is I'm going to grab a contact and throw down on the rung attached to the reset. And I'm just going to tie that to an input bit. I've already used X0 and X1 up here. So I'm going to make this X2 is going to be my reset. So then in my simulator, I can force a reset anytime I want to. All right. And so the other thing that I want to do here, though, is when my timer is done, when the timer is done, I also want to reset it to force it to start counting again. Okay. And so what I'm going to do is I'm going to copy this. So I'm over here on the T0 dot down. I'm going to paste it on the next rung. And on this next rung, then I'm going to come over here back down to timers, and I'm going to choose the timer reset. Okay, which they label as RSTT, but I'm going to drag that over there, and that's going to be for timer 0. Okay. So for timer 0, we want to reset that. All right, and so now what I'm going to do is I think that's plenty. I've got a whopping 4 rungs here. It's time to accept all these changes and then click over here on the simulator and see what happens. Okay, so you don't want to like go too far without making sure you accept those changes, and then just go ahead and pop over to the simulator. All right, now I talked a little bit last week that when you accept those changes and try to test them, you really need to kind of restart the simulator. So what I've been doing is every time I'm done testing the simulator and want to go back and make changes, I just close it. So I hit exit and just close it out each time. All right. And then you just click on it again over here to pop it open. Give it a few seconds. All right. And then when this opens, you've got to switch it back into run mode. Okay. So switch that back into run mode. And so if I enable X1, remember X1 was my start bit. So when I enable that, it turned on this virtual bit C0. And if I hit X0, it stops. And you can also see down here, the timer is running. Okay, so here the timer is running. The timer is counting up to 3 seconds, and which is 3,000 milliseconds. All right, and so after those 3 seconds, it advances the counter. Remember, X2 will reset the counter. Okay, now these buttons are hold in, they latch in. So so if you press it, you need to make sure you press it again to undo it and allow the counter to move. All right, so there's just an example of using counters and timers. Okay, and like I say, when you're done simulating that, you can just click on exit, and that will drop down there. Okay, so there's a timer, there's an up counter, and a reset of the timer. Okay, so any questions about those objects? All right, so then let's look at some others. Let me pop back up the simulator a little bit here first, and I just want to kind of look at the I/O. Okay, so we have here 16 digital inputs. We have 16 digital outputs, and again, those start counting from 0, right? So it's 0 to 15, and X0 to X15, Y0 to Y15. And then over here, I kind of pointed at these last week, but we have these analog inputs. Okay, so these are 12-bit analog inputs. And so notice they're an integer value. So as you scroll this, there's no decimal point in there. They're only integer values. And likewise, over here, we have 8 analog outputs. Okay, and so these, again, are integer kind of values. Okay. All right, so the analogs start with a W, and then it's X0 or Y0 for the output. Down here we have our counters with their accumulators, or timers with their accumulators, and then we also have little done lights that we can turn on. Okay, the D here, we saw this pop up when I did the counter. It went to like D0, which was just a integer value stored in memory. And then over here for the R, we have floating point memory locations. Okay, and so one of the things I wanted to just kind of show you here is to do some various analog sort of work. Okay, so if we come over here to miscellaneous data manipulation, I think that's a kind of a good label. That's where I went to find a move instruction. Okay, data manipulation, that sounded like, I'm going to look there for the move. And sure enough, if you scroll down a little bit, you'll find that's where the move instruction is at. Okay, so one of the things I'm going to do here is I'm going to use this move, and I'm just going to drop this move right in here, and I'm going to move timer 0 dot accumulator. So notice now when I do a dot, T0 dot, I get the accumulator, the done bits, because done bits can be made into, a done bit. If it's on is a 1, if it's off it's a 0. So it's actually a number. We can move that number around. Okay, and so I'm going to move T0 dot accumulator, okay, which is just a number, and I'm going to move that. My destination is going to be my output WY0, which is my first analog output. Okay. All right, so it gives me a little warning here. It says the following nickname needs to be defined for the move value. Okay. Assign new nickname. Hold on, what do I hit? Oh, that's my problem. Okay. It's WY0. I hit an X. Okay. And so we'll close that. Now notice here, I have no contact on this rung. So when is it going to move? Okay. Somebody want to answer that and tell me, when is this thing going to actually move? Every scan, exactly. Okay, so now let's watch what happens when I'm going to accept this. Say yes. Okay. When I accepted this, notice what it did was it put a special status bit on there. All right. So notice one of the things, right? If you bring your mouse over and just hover, they have these lovely pop-ups that give you some helpful information. Sometimes it's more helpful than not, but this here is basically a status bit that tells us that the thing is on. And so when I accepted that, it just put this ST1 status bit in there. It's just kind of something with their software. They want to have some sort of enabling bit on there. So if you don't put one, they shove this one in there. Nothing to worry about. It just basically means every scan, like Dave said. All right. So anyhow, so then when we come over here, I just want to kind of show you this. What's going to happen now when I run this? Remember, we have to flip it to run. But notice here, right, with the analog inputs, if I scroll this, it allows me to put the number in here. What'll happen is we'll get like a little blue bar here, kind of giving us an indicator of the strength or the size of the value. And then it'll actually put the decimal value in there. So I'm going to flip that over there and enable the system. And so you can see here's my counter, right? Remember, the counter is going from 0 up to 3,000, and then it's resetting. Okay, so that's all that's doing there. Okay. All right, so I'm going to go ahead and close this back out. But so there's an example of a move. In this case, I'm just moving the accumulator to the first analog output every single move. All right, but if we come over to math, okay, we can, you know, they only have a few options actually directly under math. But remember, if you just kind of come over here and hover, it shows you everything you can do. And so this math box here, also labeled calculate expression, can do all kinds of math. Okay, so this gives you a lot of stuff that you can do. All right, but notice one of the things that it's doing is when you look. Sorry, I guess I can't move my mouse there, but if you look down at the bottom there, you can see, like it says, there's a degree thing, which is converting radians to degrees, or a radian, which is converting radian to degrees. And there's also like sine functions and cosine functions built into here. But these things use radians for calculating like a sine. So what I'm going to do here is I'm going to come over here and I'm going to do a math. Okay, so I'm going to put in a math calculation here. And what I'm going to do is I'm going to store the result in R0 because I want it to be a floating point value. And I'm going to run the sine function. And I'm going to run the sine function. Okay, I'm going to run the sine function. I'm going to have to do this several times. So I'm going to start off. I'm just going to do WX1, which is the second analog input. Okay, and I'm just going to take the sine of this. Okay, so I'm taking the sine of WX1, and I'm just going to accept that and run my simulator here. Okay, and so this is going to put this in R0. Okay, and so when I guess I didn't even need to enable the system here, but we do need to run it. So now watch what happens here as I adjust this. Okay, if I go from, say, 3, okay, if I go to 2, notice it's at 0.909. Okay, if I go to 1, it's 8.47. Well, let me pop up a calculator here and let's take a look at some sine functions. Okay, so I just want to kind of remind you a little bit about sine. So I'm going to come over here to my scientific calculator, and notice that I'm in degree mode here, right? So if we do the sine of 90, so I'm going to take 90 and do the sine of that. The sine of 90 degrees is 1. Okay. However, if I switch to radian mode, okay, if I switch to radian mode, we have radians is like talking about pi. So the sine of pi, so 3.14159, and I take the sine of that, I get 0. Okay, well, in this case, I get 2.6 e to the minus 6. I get a small number. Okay. So if we take pi, which is 3.14159, divide that by 2, we get 15707. Okay, 1.5707. And so now if I take the sine of that, that's 90 degrees. Okay, so the sine of 1.57 is like taking the sine of 90 degrees. This is 1.57 radians. And so I should get 1. Well, in reality, I didn't quite get 1. I get 0.9999999. That's a lot of nines there. Okay. So, you know, if you round that up, you're going to get 1. All right. And so, but I wanted to point that out to you here. All right. Now, the problem is with my simulator here, right? What I'm doing here is I'm only going, it's an integer. So the value here is either 0, 1, 2, 3, okay? And so what we're doing is we're only looking at that first value. And so that doesn't quite work too well. So what I'm going to do here is I'm going to close this out. And what I'm going to do in my sine function is I want to divide. I want to divide here by 100. Okay. So I'm going to divide by 100. That'll give me more resolution when I slide my bar. And I'm going to accept that. And I'm going to run this simulator again. Okay, so hit run. And so now when I do this, notice here if I go to 157, okay, so I'm at 157 divided by 100, which is 1.57. Notice the value I'm getting down here under R0 is 0.841. And as I scroll along, it's going up to 909. And then it's going back to 0.41. Okay, even though I have this resolution, what's happening here is kind of a weird thing. Okay, what it's doing is it's taking WX1 and dividing it by 100, but it's making it an integer. So it's losing the decimal point. Okay. So one of the things that we can do here is to try to play a game. I can tell it to divide not by 100, but 100.0. By putting that decimal point in there, what it forces it to do is put a floating point number and not make it an integer. All right, so I'm going to accept that and run this again. Okay, and now when I run this, okay, notice when I get over here to 157, actually I'm at 154. Okay, so but notice that I can get up here, it's only given me 3 significant digits. So that's why this whole distance right around here, 1, 5, 6, 7, 8, 9, it's a 1.00 because that's like, remember when I did the calculator value, did I close that? Yeah, I closed that, but I had like 0.9999999 sort of thing going on in there. And that's what's happening here is it's rounding up as we get close to that little hump. All right. So, but the trick here is the fact that if you don't put that 0.0 in there, if you don't put that 0.0, whoops, you don't put that 0.0 in this expression calculation, it's rounding it up and it's doing an integer calculation instead of a floating point calculation. And so it's basically truncating anything below the decimal point, and your accuracy is really going to suffer. Okay. So is there any questions about that? This is a trick. I've seen this with a lot of different types of programming languages and stuff, that it's like if you don't force it with this .0 here, it's doing an integer. You have the integer, because remember, WX1 is an integer value, right? That's your analog to digital coming in, and it's a binary number. There's no decimal point in it. It's just pure integer. And so then when you divide by 100, you're getting an integer value. So it's either a 0, a 1, or a 2, or a 3. Okay. And so it's ignoring any decimal points. So to force it into a decimal point, you force it with this divide by, something .0, or multiply. If you were doing multiplication, you multiply it, don't multiply times 2, multiply 2 times 2.0. All right. And that will force it to do floating point math. And so it won't just round it off to the integer value, but it's something you got to definitely be aware of. Anytime you have any kind of weird, you're doing these calculations and you're like, why are these numbers off so much? Well, it's probably because it's an integer to integer calculation, and it's just truncating any decimal point, any fractional piece, anything to the right of that decimal point is just throwing it away. All right. So, but if you play a game like this and when you do your math, you force it with a decimal point in there, it'll force it to do floating point math. Okay. And like I say, I've seen this on a lot of different programming languages and stuff, that you kind of need to play this game sometimes. All right, so any questions about that floating point? Did you see the difference there with without having that decimal point, right? It was basically just doing 150 divided by 1 and giving me that 0.8, because the sine function was giving me floating point, but the sine function was only operating on an integer. The decimal point, it's not that it's one decimal point there, it's the fact that I had to put the decimal point or it was doing integer math. Okay, so I could put 3 decimal points here. Since they're all zeros, it makes no difference. Okay, but anytime you're trying to do any math calculation and you expect it to have a fractional piece, you expect it to have a decimal point in the answer, then you need to put that decimal point there. So yeah, pretty much any sort of math calculation, maybe in some other places, but definitely with like this calculate expression, if you want to do decimal point math, if you expect it to have a something to the right of the decimal point, you need to make sure you do that calculation with the decimal point. And that tells it, hey, don't throw away everything to the right of the decimal point. If you don't, it just throws it away. It's like, computers like to do integer math. That's their favorite. And so that's what's happening here. right, so let's see. So there was a sine function. I think that's really about it that that you need for to do your homework. Okay. So is there any other questions there? All right, so let me just kind of review this again. Just shut off the simulator. You can shut off the simulator by clicking on this button. See how it's not highlighted right now? If I click on it again, then it restarts the simulator. And now over here, it's highlighted telling me that the simulator is running. Okay. So you want to shut off that simulator and then make changes and restart it. Okay. So that you make sure that those changes apply. No, these empty lines down here mean nothing. Okay, it understands that there's nothing on these empty lines, so you don't have to like worry about going through and trying to delete them. Okay, it will just skip them. Okay, it's just kind of the way the software is built. They have those lines there for you to use, so you don't have to recreate them until you run out of what they give you. Any other questions? All right, so I'm going to save this. Okay, and that now, you might want to save it multiple times as you go through there. If you wanted to create a new program, you come over here, say new project again. Okay, so I'm going to say new project, offline. It's going to be a simulator. Okay. I guess I could have named it right there, but I'm going to come over here and say save project as. And again, I just want to make sure I save this under documents. Okay, so when you save this, that's why you really need to do the save as. So you need to come save it, Hartman do more. Okay, and then the next one I think was called the railroad. Okay, and I'm going to save that and give it my comments or whatever and create this program. Okay, and so I'm going to, just dump this on here, X0. Okay, and I'm just going to click, see, it won't let me accept, it won't let me accept the changes until I get the wrong working, I guess. Okay. And that was X1. And then I'm going to have my coil. Actually, when I'm on X1, remember, if I want to do my drop down, control drop down will give me that drop down. And then I can come over here and I could add my bit C0, and then up arrow will return that. That's pretty cool. I like that up arrow, down arrow. I'm glad I took the time to read the little help bit over there. That makes it really fast. And then I'm going to add my coil. Okay. All right, so I'm just going to accept this now and save it, but it's saving as railroad. All right, and now I just want to show you how to zip files. I mean, I know most of you probably know it, but in case you don't remember, we're going to come over here to documents. So I just open up my file manager, and I'm going to come to documents, and then here is my file, Hartman do more. I'm going to right click on this, send to compressed zip folder. Okay. File not found or read permission. Send to compressed zip folder. Oh, I don't like that. Not sure why it's giving me that. I'm going to copy it over here under users. It might be this laptop. Okay, oops. I'm going to paste It might be because I left the file open. Maybe that's what it is. Okay, so let's come back over here. I'm going to go ahead and close out of the designer because I have that file open. Maybe that's what it's complaining about. Okay. So Windows doesn't like for you to do things when files are open. So I'm going to try this again. Okay, so and the name should just be then Hartman_do_more.zip. Yeah, so that's what it was doing. I had the yeah, I had the file still open. One of the files inside of the folder was still open, and Microsoft Windows for some reason doesn't like you to mess with files if they're open. They put these special locks in there to prevent you from I mean, to me, I don't know why there was a problem with adding it to a zip file, but apparently Microsoft didn't want me to add it to the zip file with it open. So I just closed the designer, came over to my Windows File Manager, selected the file, did a right click, did a send to compressed zip folder. So here is my zip folder now, and it's still under documents. So, but there is the zip file. So now what I'm going to do is I'm going to come over to Blackboard, and I'm going to upload this into Blackboard. So I'll come over to my Blackboard window. Okay. And I'm going to click on this assignment here. Let's see. I might have to go to student view. Now I've made Blackboard mad. I'm having a good night. Hopefully you get your guys is going better. All right, come on Blackboard, any minute now. All right, so I click on, I clicked on the assignment, okay, and then here it says attach files. So this is under assignment submission. I'm going to attach files, browse my computer, go to documents, and you want to grab the zip file, okay, click open, okay, you should see the file there. And you know, don't change the link title name, please, and then just hit submit, and it should upload that document. Submission from previewed assignment is not saved. I think that might just be me. Okay. All right, and then you should be able to submit it. I think they give me the student view. I seldom ever use it, but I think it's just mad because I'm instructor, and so at least I hope that's what it's complaining about. So browse computer. Okay. So yeah, so I went to the assignment, click on the upload assignment, scroll down to assignment submission, browse my computer, go to documents if it's not already open, hartmandomore.zip. I've already compressed it, so I'm select open. There it is. Hit submit. There we go. That's what you guys should be seeing is success. Your submission appears on this page. Okay. And so I think it just because you know as an instructor I kind of have a different view, so it just didn't want me to submit it there. Okay, so I had to go to this special thing that they give me to pretend I'm a student. Okay. All right, so that's how you then upload your zip file with your 3 files in it for the program. All right, so that is all you really need to do, I mean, you guys need to go through the entire lab and do all the ladder logic and stuff, but that's all I was going to do as far as the lecture piece for today. I just wanted to overview that and show you that. And then, so this is kind of you guys' uh, chance to go work on that. Okay. Matt, I just saw your question about the autosave. Um, yeah, I guess I haven't tested any kind of autosave, but I've noticed with this software that if you don't accept those rung edits and you try to do an undo, it undoes the entire rung. Okay, it wipes out. You may have like done 3 or 4 different things on that rung. It wipes them all out. Okay, so I recommend clicking that accept changes quite often. Okay, and then go ahead and click on the save button quite often too. I haven't worked with this software very much yet, so I'm kind of, anything new, I want to make sure I save my changes so I don't have to rebuild everything from scratch because I did an oops. Okay, so yeah, so I recommend doing an auto save quite often, or not a manual, not an auto save, but a manual. Click on the accept rung edits and then the save button. Do that quite often. All right, so any other questions with that? If not, I'm going to stop recording here and I'm going to stay on and you guys can work on your labs. And if you have a question, just click on the raise hand or whatever. And, and just I'll kind of be here monitoring this.